Good morning, children. So, how are you all? Hope you're all good. So, in the previous session we discussed about how metals can be extracted. What are the main steps? Okay, we had a brief introduction. So, if you just recall, we'll discussed about three steps. What were they? First, enrichment of ore, that is concentration of ore. And what we do in that process, we just remove any kind of external physical impurities. Okay, and then after extracting the ore, then after extraction of ore, now extracting metal from the ore. And then finally the third stage, that is the refining of the metals. So previous session we just had an introduction about enrichment of ore, that is by removing the impurities. And how are we removing these impurities? By following certain separation techniques. Okay, then comes our second step, which is called as extraction of metal from ore. Now children, if you remember, all the metals have been arranged in the order of a series, which is termed as, yes correct, it is called as reactivity series. Now, depending upon where the metal is lying, whether it is in the higher order or in the middle order or in the lower order, the extraction of metal from ore will follow different techniques. Okay. Now, as I said, most of the metals will be found in the present in the form of their compounds, and especially in which form of compounds? Carbonates, sulfates, and oxides. And among all these, the most abundant is oxide. Why? Because oxygen is very readily available in nature and which readily reacts. So most of the ores will be in what form, children? Either in the carbonate form, sulfate forms, or in the oxides. Okay. So now, whatever may be the procedure we apply, we have to extract the metal from this oxide or sulfide or carbonate ores, and this will vary from metal from a higher order to a middle order or to a lower order. So today we will be discussing about how metals will be extracted from ore in the lower reactivity series. Now if you can recall, this is our reactivity series. So if you see, it starts with potassium. These are which order? Highly reactive order. This is your middle order and this is your low reactivity lower order. Okay, so these are highly reactive and these are moderately reactive. These are moderately reactive and these are least reactive, and these are highly reactive. Okay, so now today we will learn about how the metals in the lower reactivity series will be extracted from their ore. Okay, so now if you see, which are the metals which are lying in the least reactive series? Yes, copper, mercury, silver, gold. Now remember children, most of the time gold and platinum are extracted in their free state or the native state. Copper, mercury will be existing most of the time in their oxide state or the in their compound state, preferably sulfide state. So now let us today start our discussion first with water, mercury. Now mercury commonly found as an ore by name cinnabar. What is the name of this mercury ore? This is known as water cinnabar. Now just let me write the formula. I hope you can guess the chemical name. So what is the chemical formula? HGS. So chemically we call this compound as mercuric sulfide. Okay, what is this called as? Mercuric sulfide. But the ore is termed as water cinnabar. So this is most commonly found ore in the nature. Okay, now remember, since these are low reactivity series metals, there are two steps which are followed in order to extract the metals of the lower reactivity series. Okay, how many steps, children? Two steps. Okay, what is the first step? Step 1 will be converting the sulfide ore to oxide. What is the first step? Converting sulfide to oxide, the sulfide ore to oxide. And what would be my step 2? It would be converting or extracting metal from this oxide. So conversion of oxide to metal, which is normally a what process? Reduction. If you can recall the definition of reduction, what is reduction? Reduction is the process of removal of oxygen or adding of hydrogen. So the second step is also called as reduction process, that is obtaining metal from its oxide. So children, so what are my two steps to extract metals from the low order? Step 1, converting the sulfide to oxide, and step 2, converting the oxide to metal. So as I told, mercury will be existing in its sulfide form, that is called as, commonly referred as what? A cinnabar. Okay. So any kind of low order reactivity series will follow two steps, children: converting sulfide to oxide and oxide to metal, and both these process involve the heating. Okay, and this is done just by process of water heating. So now let us discuss first the step 1. So now step 1 is what? Converting my sulfide ore to oxide. Now how do I do this? Okay, now what is going to be done is, the sulfide ore, that is now here, what is my sulfide ore here for mercury? Mercuric sulfide cinnabar will be heated in the presence of oxygen. So we can say more or less it's a sort of combustion process. So when it is heated, now remember what is the state of oxygen? That is gaseous state, and this is in which state? A solid state. So sulfide ore or cinnabar, when it is strongly heated in presence of oxygen, it results in the formation of mercuric oxide into water, mercuric oxide, liberating a gas called as your sulfur dioxide. Now here children, when you are writing the equations, the physical states should be definitely mentioned. Now what was the physical state of mercuric sulfide? It was solid, and even the mercuric oxide which is obtained will also be in which state? A solid state. And what is this? This would be gas. Sulfur dioxide is going to be gas. So now my step 1 is done. Okay, so what was my... So now children, let us now move on to what? Step 2. So what did we obtain in our step 1? We obtained oxide. From where? From the sulfide ore. Okay. Now what is my what is my step 2? My step 2 is converting oxide to metal. Now generally this is termed as what? As I mentioned earlier, reduction. Why it is reduction? Because it is, why it is reduction children? It is reduction because I am going to remove oxygen. Okay, it is the removal of oxygen. Okay, so now let us see the reaction procedure. So now what is the reactant I would be taking up? It would be my mercuric oxide, HgO. Now it will be, again the process is same, simple process, heating process, but here it is no more oxygen is going to be involved. Now this mercuric oxide will be heated to a temperature range close to 300 degree Celsius. So when it is strongly heated to a temperature of 300 degrees Celsius, this mercuric oxide gets converted to mercury with the liberation of oxygen. Okay, now here if you see the mercury which is obtained, as you all know, what is the title given to mercury? It's a liquid metal. Very good. So this is going to be in which state? A liquid state, and here it would be in which state? A gaseous state. Okay, so you are clear now, I hope children. So remember, lower reactivity series, two steps. Step, converting sulfide to oxide. Step 2, converting or reduction of oxide to metal. Okay, so now here we have discussed one example of metal from lower reactivity series, that is our mercury. Now let us discuss one more example, that is your copper. So now let us discuss children the second metal, that is copper. Now copper, as I told, it also exists in the sulfide ore. Now the sulfide ore of copper is called as copper glance. Now what could be the formula of this sulfide ore? This is Cu2S. Okay, so cupric sulfide, it is also called as what? Cupric sulfide, copper 2 sulfide. Okay, now copper 1 sulfide. Okay, Cu2S, because if you crisscross the formula, sulfur has 2 valency and copper will be 1. Okay, so copper 1 sulfide, that is nothing but your cupric sulfide. Okay, now just recall children, what are my 2 steps for extraction of metal of low reactivity series? I hope you can now recall. Yes, step 1. So what is my step 1? Conversion of sulfide to oxide. So what is my sulfide over here? That is copper glands, nothing but water, Cu2S. Now this Cu2S will be, again, as I told, the simplest process, that is heating process. So it will be heated strongly in presence of oxygen, which results in the formation of copper 2 oxide and with the liberation of sulfur dioxide. Okay, with the liberation of copper, copper 1 oxide, not copper 2, copper 1 oxide, cupric oxide, with the liberation of sulfur dioxide, which will be in which state? A solid state. And this is also in which state? Solid state. So strong heating to obtain copper cupric oxide. Now what is my step 2? As we have discussed earlier, conversion of this oxide to metal, or reduction of the oxide to metal. Now here a tricky thing happens. Here what is going to happen is that as the reaction happens, that is conversion of copper sulfide to copper oxide, almost when 3/4 of this copper sulfide has been converted to copper oxide. How much, children? As I told, 3/4. 3/4 of the oxide, I'm sorry, 3/4 of the sulfide is converted to water oxide. Then they are going to stop the supply of oxygen. What is going to be done? Supply of oxygen is going to be stopped. So when the supply of oxygen is being stopped, the reaction happens, the reaction being carried out wherein there is a major portion of copper oxide with a small amount of copper sulfide. So the reaction goes like this: Cu2O plus Cu2S. In the sense, we are allowing this sulfide to react with the oxygen which is available within the reaction mixture. So ultimately it results in the formation of your copper and releasing sulfur dioxide. Now this copper is going to be in which state? A solid state. Okay. And this of course will be gaseous state. So it is little different here. We see that oxygen supply is cut off when almost the reaction has reached. So children, today what did we discuss? We discussed the second step, that is nothing but the extraction of metal from ore. And which ore we have discussed from the low reactivity series. And two important metals we discussed, that is one of mercury and the other of copper. So copper, which is the ore is called as copper glands, and cinnabar, the ore of mercury. And these both are which ores? Sulfide ores. And step 1, what have we done? Converted sulfide ore to oxide. And what was my step 2? Reduction or conversion of the oxide to metal oxide to metal. Okay, so this is about our low reactivity series, and then we will be discussing about the middle order series in the next session. But remember, this will be the common step, and then the refining of the metals will be very common for all the metals of any of the series. Okay, so we'll discuss in the coming next class regarding extraction of metals of the middle order series. But thoroughly today revise the chapter, and please, your video is with you, go through that what all I have been writing, and just do underline the page, and also write down the keywords, okay, because some of the terms are missing in your textbook, so do write there. Okay, thank you children, have a good day.